Same resume, same LLM, same prompt. Python scored it 72, Java scored it 57, and I had no idea why. That's the thing nobody tells you about switching languages for AI. The model is the same, but everything around it changes. I built the exact same agent twice to find out what. The agent that we'll build is a resume roaster. You give it a PDF, it gives you a brutal, honest score, a tear down of every weak section, and a rewrite of your worst bullet points. The kind of feedback your friends won't give you. I picked this as the first comparison because it's simple. One LLM call, structured output, no memory, no tools. If you can spot the differences, even in something this simple, imagine what happens when the agents get more complex. So let's build it. Talking about the architecture, it's a three-step process. First, you parse the PDF into raw text. Second, you send the text to a LLM along with the strict output schema. And third, you get back a structured object with a score out of 100. Category breakdowns, the roast, and rewritten bullet points. Just one LLM call. That's simple. Both Java and Python versions do exactly this. The difference is how they do it. Let's start with the easier and more familiar one, that is Python. The whole thing is just four files. So the first file that we'll be visiting is models.py. So the first thing we need is the output schema. And for that, we are using Pydantic models. So we define what all we want back. The overall scores, and the score will range between 0 and 100. For each fields, we are provided the overall description that we want to give to the LLM. Next, we have roast, the weakest section, and this will return the list of all the weak section and its call out. Then we have the rewrites, and towards the end, we have the verdict. And the nice thing about Pydantic is it enforces all of this at the runtime. So if the LLM returns a garbage, it throws an error, no silent failures. So now let me show you where we are doing the actual LLM call. Let's go to roaster.py. So for doing the actual LLM calls, we are using LiteLLM. So here you can see we have this LiteLLM.completion, and it takes in two things, the model and the messages. So the model that we are passing right now is GPT 4.0 mini, but you can change it to Olama and run it freely on local, or you can change it to Anthropic and then start using Claude. Same code, any provider. You can get the flexibility basically for free in Python. And then we are passing the messages. The first one is the system message, and the second one is the user message with the actual resume text. One thing to notice here, we are injecting the schema that we had created with the models directly in our system prompt here. So you can see we have added this resume roast dot model JSON schema. So it will bring in the full resume roast that we have created into our system prompt. So we are telling LLM exactly what shape to return, and then Pydantic validates the response on the other side. It's all manually wired up, but honestly, it may be almost 10 lines of code. Okay, let's move to the other file. Here, this is the simple one that we have, that is the resume parser. It takes in the PDF, extract all the text, and give back a string. Next, let's move to main.py. So it is the one that orchestrates everything. You pass the PDF path, it then extracts out all the text over here, and then it calls the roast to roast your resume. Later on, towards the end, it's printing the exact result that it has got from the LLM. Okay, now let's build the same thing in Java using Spring AI, but the way we'll be doing this will be a lot different. So let's go to the Java implementation inside the src, Java. And the first thing that I want to show you is the outputs that we'll be getting from the LLMs. So this is the roast response that we have. Similar to Pydantic that we had in Python, we are using records over here. And you can notice this JSON property descriptor annotation. What these do is describe each field to the LLM, and Spring AI reads this annotation, automatically builds the JSON schema for you, so you don't have to inject it manually like we did it in Python. So the output will be same. We have the overall score, category scores, and the weakest section, rewrites, verdict, same as we had in Python. Okay, let's move to the service, and this is the roast service. As we are using Spring AI, so we are using the chat client to do the actual LLM calls. Chat client under the hood uses chat model. You just add the right implementation jar in the Maven and Spring wires it up. So I'll show you how we have passed the correct jar, and you can see we are passing the Spring AI OpenAI starter. So what Spring does out of the box for us is it binds the OpenAI chat model implementation with your chat clients that you have used over here. So tomorrow, if you want to change the LLM provider, you can just change the implementation that you have given in the pom.xml, and Spring will wire this up out of the box. I know this is not as straightforward as we had in Python, where you just have to pass in the correct model and LiteLLM handles everything on itself. Let me show you how we are actually using the chat client. So we are using the chat client builder and passing the system prompt that we have mentioned in system prompt.txt. Next, in order to call the chat client, we are passing the user message along with the resume text that we have extracted, and then there's a blocking call function. Now, this is the part that surprised me. When you call .entity, Spring AI handles everything. It generates the schema from the annotation, injects it into the prompt, passes the response, and maps it back to the Java object. All that manual wiring, we did it in Python. Here it's just one method call. If you want to go deeper on Spring AI specifically, I have a full course on Udemy, and its link is in the description. Next, we have this resume parser where again we are doing the same thing. We are reading the PDF and extracting out the string. And as this is a Spring, we end up getting the REST endpoint as the result. So you can post your PDF and you get back a JSON. It's not a CLI script that we had in Python. It's deployable service. So it's overall 7 files, 214 lines compared to 4 files that we had in Python. All right, let's run the Java part. So we'll be using MV and Spring Boot run. And at the same time, I'll also run the Python one. So let's write down UV sync. It will download the dependencies. Okay, so this was already done for me for Python. Okay. One thing that you have to make sure before running your code is to provide the correct LLM keys. For Java, you can go over here in the application properties and replace this with OpenAI API keys. So the model that we are using is GPT 4.0, and you can do the same thing for Python. So go inside the python.env and you can provide your OpenAI keys. Now, I have already set the OpenAI key in my environment. So I'll just run my code. So now both of our projects are built. So let me try running them. So for Java, we'll be using the curl command. I'm passing my CV to this roast, and we have given the path for our roast API. Let's hit send, and parallelly we'll do the same thing for Python as well. So here you can see we are using UV run Python and the main file name. and we are passing the PDF. Let's hit send here as well. Here you can see we have got this full JSON output. Let me copy this. Okay, okay. I've copied the response and we have got the response from Python as well. And let's go back to VS Code and I'll show you the responses. And you can read the roast. It's quite hilarious. The resume is poorly structured textbook where every bullet points feel like it's trying to say something profound but ends up just being a collection of buzzwords and a vague responsibilities. And you can read the resume here as well. It says a laundry list of the buzzwords and responsibility with zero impact. So the roasts are hilarious. Next, you can check out the category scores, and Java has given the overall score of 50 and Python as 52. Now, the scores might be little different, and that's totally fine. That's how the LLM works. You'll get slight variation between runs, even with the same prompt. The point is, LLM doesn't care whether it's Java or Python called it. What is different is everything around the call, and that's what I actually want to dig into. Okay, so now let's talk about what actually changes when you pick one over the other because the roast outputs is similar, but the experience of building it is pretty different. In Python, you write a Pydantic class, then you manually dump that schema as JSON, put it into the prompt, the LLM sees it, returns JSON, and Pydantic validates on the way back. You are writing all this yourself. It's about 10 lines of code. In Java, we are using record with JSON property description and then just one call dot entity. That's it. Spring AI reads the annotation, builds the schema, injects it, parses the response, and gives back you a typed object. So one line replaces everything you did manually in Python. This is honestly where Spring AI impressed me. And the second difference is switching LLM providers. With Python and LiteLLM, you just change one string, swap GPT 4.0 mini to Olama, and you are running locally. Same lines of code, any provider. With the Spring AI, you need to swap Maven dependencies and update the application properties. It's more steps, but it's way clean. And the trade off is you get a proper provider specific starter with all the config option exposed. So it really depends on whether you want this flexibility or control. So what you get at the end with Python, you get a CLI tool, you run it on the terminal, pass it a file path and get the output. It's fast to build and useful for yourself, but if you want to share it or deploy it, you need to wrap it something around fast API, add a server, set up health checkups. That's basically a separate project. With Java, you get a REST API out of the box, post PDF, get back a structured JSON, and all production stuffs that Spring Boot gives you, like actuator endpoints, thread pools, it's already there. So you're not far from deploying it. And the last difference that I have is Pydantic catches type errors at runtime. So only when you actually call the agent. Java catches them at compile time before you even run anything. For a simple agent like this, it honestly doesn't matter much. But think of a multi-agent system with 10 models passing data between them. That's where it matters a lot. You want the compiler catching schema mismatches, not finding them in the prod. So my take is prototype in Python, ship in Java, at least for this kind of agent. Both the repos are linked in the description. Go run it on your resume and drop your scores in the comments. And if you get below 50, tell me what does it roasted you for. In the next video, I'm building an agent that reads my AWS bill and finds where I'm wasting money. So subscribe so that you don't miss that. And please hit that like button. That really motivates me to make more videos like this.